I am part of the user services team for eSimplicity, and I have the great pleasure of talking to you all today about Spark Explained. So yeah, let's get into it, right? Our lunch and learn today is how Spark thinks, making sense of .explain and Databricks. So have you ever wondered why your query is taking longer maybe than expected to run, right? Like your data frame makes perfect sense to you. Everything seems like it should be working right, but for some unknown reason, right, everything is just taking much longer than expected to yield your results. And over the last couple of weeks, we've actually had an office hour, an interactive session talking about scalability and scalable code. And in both of these presentations, Katie and Tim brought up Spark's explain function. So today we're going to deep dive into .explain and kind of make sense of what's happening behind the scenes when Databricks and Spark execute your code. So first off, what is .explain? So the Spark explain function displays the execution plan that the data frame is going to go through, right? That's what Spark is going to use to actually execute the data frame you've built out in your PySpark or Sparkly R code. And so this is really helpful for us as programmers or coders or data scientists or data analysts and trying to optimize our code, do any debugging, any evaluating of the efficiency of our code or joins or anything like that. And by understanding this execution plan, we can identify bottlenecks, right, such as any data shuffling or full table scans, and we can try to prevent some of that or try to account for that or just be mindful of it. And so, right, when we talk about execution plan, we're going to look at them down below. This details the different processes that Spark is going to utilize to execute your code in the most efficient manner that is available, right? And Spark is going to do all the heavy lifting to try to be efficient. But if we write inefficient code, then Spark is going to be inefficient. It can't kind of magically do anything, right? It's going to be confined to how we tell it to do things to a certain extent. All right, so we're going to look and we see that there are two really primary components of the explain function, and that's the logical plan. So this lays out the high level of operations that Spark will need to perform, right? Think of it as really just kind of the what's going to happen without really the how, right? And we'll actually see down below there are two additional components to the logical plan or variations, how you want to call it, the analyzed logical plan and the optimized logical plan. And then so we also have the physical plan. So this is the default setting. This is the default output that you will see. And this really lays out the actual concrete steps that Spark is going to take to perform this plan. And it's the description of the how. How is everything going to be executed? It's going to show you the details about the operators, any data shuffling that Spark is going to do on your behalf, and then any partitioning that might happen, again, due to whether Spark needing to do it or you calling out something explicitly in your code. So yeah, let's dive into the further. Right, we're going to set up just some basic libraries that we typically utilize, and so now we're gonna set up a data frame. And I figured we'd use the sample cars data from our community catalog. So, we're just reading in Spark SQL, select all from this cars table. You can see here, we got just small table, 428 rows, just general statistics and details about, maybe not statistics, general details about these cars. So, now that we have our data frame, we can actually call .explain and start looking at what's happening behind the scenes, right? And so at the very beginning, if you don't put anything in these parentheses, you're going to get a very simple output. For a simple query, that's fine enough for us. And so you'll see below, right, we got the physical plan. That's the only one that's going to show up for the base explain, right? So we didn't call out any additional parameters in our function. And in the physical plane, you actually can see that, we've got something happening, columnar to row. And this is where Spark is going ahead and converting that data frame from a row-based kind of piece of data into a more columnar Parquet file, which Spark likes to use to quickly access and kind of catalog data for its ease of use. So then moving on, right? So we've got the basics down. We're going to start adding in parameters here. And so there are 4 different parameters you can add into the .explain to get more information about what's happening, right? So if the .explain doesn't show you maybe what you're looking for, doesn't really give you any clear example or input or explanation of why things might be slower, we can use some of these extra parameters. So we'll start off with extended. And here we can actually see that you're going to see what's called a parsed logical plan. And this is Spark's initial blueprint of the transformation. And then following on to that, right, the analyzed logical plan builds upon this by checking the field types, right? We're going to make sure that all the types of everything make sense, right? You're not trying to do, calculations on string fields or anything like that. We're going to make sure that the data exists in these fields, and that any other functions that you're actually calling have everything needed to be run, right? So the analyzed logical plan just really makes sure that everything that you're trying to do can happen when it comes to Spark actually trying to execute it. And then the optimized logical plan will build upon this analyzed logical plan, right? And actually start moving data around if needed. And the optimized logical plan is ultimately what Spark does try to execute when it comes to actually executing your code. And for additional information, we do have great resource in the office hour topic 5, working with data frames in Python, that showcases actually a great table to show from job submission to task execution of what happens step by step. So here we can see here, right, we got same data frame, haven't changed anything, going to .explain with the mode extended. You can see here our parse logical plan is just kind of reading in, seeing what's there. Analyze logical plan, you can see here I got every column, checking the types, kind of laying out a quick project for it to start to think about what's going to be happening, making sure everything's there. And then the optimized logical plan is ultimately what happens with that project to start to compile everything together. So then we have the, instead of using the extended mode, we can also use the formatted mode as a parameter. And we're going to see more kind of an explanation of what's happening on the physical plan with the formatted. So here you can see the physical plan. It's going to do the columnar to row to get it into like that Parquet file. And then so it does the scan on the table, seeing where the table data is, making sure everything there is, checking the schema and the type. And then you can see there again, same kind of ultimate outcome is that it's still going to be, processing the data in the same kind of way. So we do have some additional parameters that are less likely to be used on a general basis. So we have a parameter called cost, which will actually show you the statistics of your columns if they are available, or Spark is able to intuitively, get that data. And then we also have the parameter of cogen, which will display actually line by line the background code that Spark is actually using, which is written in like Java and Scala, which is, really interesting, really cool to see. But unless you're actually trying to rewrite Spark, it's not really pertinent. But But yeah, so you can see here, with our cost parameter, you can see right in, highway miles per gallon highway, we've got 32 distinct different, MPGs. The lowest one is 12, the highest one is 66, the average length is 8. I mean, so there's some definitely high level statistics that you could check out here. Unfortunately, no quick, easy way to distill this information that I have found to actually utilize it in any kind of code, but for your own, preparation work as you're trying to figure out the best way to tackle a table, if this is helpful, it does exist. And then same thing here, just a quick snippet of the top of what pops out with the code gen. So you can see here, it's working up the tree and trying to understand how many, different pool size it's going to do, and just kind of like how it's going to actually build out that Java code. And then you can see here, right, that's actually getting into the Java code. And this one here was like 100 and something, I think like 130 something lines long, just to process this really simple, select statement. But that's what happens on the background or back end. And if you are one of our prominent R users, you can still use the explain method in Sparkly R, right? So, same thing, I have to just set it up and it'll print you out the physical plan. So let's take a look at some actual more detailed code examples to see what's happening on the background, right? So here we've got our regular, data frame. We're going to filter it. All right, I'm a family guy. I got, a family to take care of. I want to buy a new SUV. I want to make sure it's got all-wheel drive so that if it snows, we're not going to, spin around on the road or anything like that. But we want to be safe, SUV. So let's look for that, right? So put in that, and the interesting thing with Spark is that I know we've mentioned it before. It is lazy execution focused. So when you're using things like filter or select, those operators are really just telling Spark to kind of keep this data kind of in mind. And it's not actually going to do anything with this data until you actually call it with like a display or show or collect. So you can do a lot of data manipulation that will be very quick. And all it needs is to create this, execution plan. Spark keeps that in mind, and then it'll actually execute it once you go further to something that is eager. So we've filtered our data, and you can see here, right? So it's going to do the column to row. It's going to check it, and you can see we've got the dictionary filter. So it's actually filtering all of our data as we're ingesting it from that location on these two fields, so that it really only pulls in the data once it does actually execute this that it needs. So it tries to minimize extra shuffling around or anything like that. We can see more of that in this extended version. Excuse me. So you can see here, right at the very beginning of the plan, it wants to filter drivetrain, and then filter the type. So Spark wants to get only the data it needs for, its purposes as soon as it can. And the more we can be mindful of that, more we can think about that, the better. So that's a good reason why this dot explain is helpful for that situation, right? We can see that if it's going to filter, it's going to filter as soon as possible. And we need to think about that as well, right? If we're doing a bunch of calculations and queries and then we're trying to filter it at the very end, we might want to shuffle that up if possible. We might want to change our way of thinking to match more of the execution plan if possible, to help expedite our code or make more efficient our code. So yeah, so parse logical plan, we're filtering, again, checking schema types, and then filtering an optimization plan. See there, filter is the very first thing we're doing. So again, it's trying to take care of all that first. And then puts out our, so we're going to call display, and that's where it will actually do this physical plan that it tells us it's going to do. So then, like, if we're going to do some aggregations, right, we want to do some group by of like make and type by the average miles per gallon and highway, or sorry, horsepower. We can do that here, right? So we've got this, and we're going to do group by and aggregation, then order by, and right. So let's do the formatted, and we can see there, you know, it's going to shuffle some stuff around. It's going to do the sorts early, and so then we can see here, right? It's focusing on the 4, right? Make, type, and then horsepower and miles per gallon highway as it's reading in the data. Again, you know, doing all the calculations for the averages there on the back end. And then as it groups stuff together, it's still keeping all that in mind. So you can see there's a lot of stuff happening here to show that, you know, Spark moves stuff around as it's needed, and, you know, it prepares to bring everything together in the most efficient way, sorts as it needs to, as it's most pertinent. And we can see here, right? So part of it, if we try to sort it ourselves first and then do the group by, you know, that's actually kind of making Spark think about it too much in the beginning first. So, you know, trying to think of it again as how Spark would think of it, or, you know, utilizing these dot explains to see how Spark thinks of it and understand that it's going to want to group as much of it can together before doing like the final sorts, and it's going to sort maybe 1 or 2 times sometimes throughout the process. So trying to force it to do something early on can mess up the efficiency of your script. All right, so let's try a couple joins, and, you know, we'll just do a mock data frame, right, of speeding tickets. So we'll just see, and so we want to join this to our cars data, and we're going to do a simple inner join first. And so we can actually see that Spark is going to use a broadcast join to make this the most efficient join possible. So what that's going to do is it's going to take this small data frame we have here and broadcast it to every worker node doing any kind of work, so that it has it readily available there, because the data frame is small enough to do that on. If it were 2 bigger data frames, it might actually use a different sort merge type join or something like that. But you can see here, like, we didn't even have to call that it was a specific broadcast join or anything like that. We just said, hey, join these 2 data frames together on make and type, you know, using the inner join. And so I just took a couple snapshots here because, again, it prints out a lot of long information. So you can see here, right, it's going to do a broadcast join. So it's sending that speeding ticket table out to all the worker nodes. It's going to filter that table, or it's going to filter both of them to make sure they match. And then you can see here, right, we're joining on make and type, make and type. And you can see it tells you there, right, broadcast join on inner with no extra conditions. So then we can also see, right, if we did a left outer join, right, the broadcast join is not going to be the most efficient method in that sense. So the execution plan will actually show us that the right side gets filtered. Again, just being mindful of that, right? If the data frames are extremely large, knowing that it's going to filter the data to what it needs to join it anyway, if possible, you know, we might be able to filter it ourselves before it hits this point to save some time. So again, this would be a left join. and see here, no broadcast join mentioned, but we do get this sort merge join. So again, we're going to get that filter on the right side of the join to actually make the speeding ticket data frame match up with our car's data frame in there. So that's your join actually happening there in step 12 of 13. So, right, as we wrap up here, Spark's .explain function is extremely helpful, right, when diagnosing unexpected bottlenecks or inefficiencies in your code. If you're trying to design an optimization plan, or if you're just running into things that, you're doing debugging, right? If the code isn't outputting at all, anything like that, maybe .explain would help us see what's going on there. And you can see that we have multiple parameter options that we can use to actually evaluate the code to see what's going on in the background. And by seeking to understand what is actually going on behind the scenes, we can proactively build more efficient code. Right. So if we make use of .explain while you're doing your development, hopefully that will help you avoid headaches and wasted time spinning your wheels trying to figure out what's going on just by guessing. Right. .explain hopefully will help you get to the root cause of the problem, or at least get an idea of the root cause of the problem. And like I said, we will link also to Tim and Katie's recent presentations as well, because those were extremely helpful with .explain and had a lot of information there as well. So when this goes up on Code Commons, there will be a couple other links in here to some other previous presentations. But appreciate you all for joining today. I'll hand it back over to Laura, I guess, at this time.